Welcome back to the simple solution! Woo! Anyway, sorry headphone users, but today we're going to be reviewing nomenclature.
Let's start with binary 1. So let's go over some rules. Binary 1 involves groups 1 and 2 plus nonmetals are polyatomics.
Whoopsie.
No prefixes are in the name, and it does not account for the numbers in the compound.
So let's practice on how to pronounce binary 1. So first you're going to say the first element, which is the one on the left, as it is on the periodic table. The left element is also known as the cation. Next, you are going to say the anion, which is also the element to the right, with the "-ide suffix. Let's practice.
NaCl. So sodium is in group 1, and Cl is a nonmetal. Therefore, it's binary 1. So the name would be sodium chloride.
Let's move on to a new example. We have magnesium and we have chlorine. Magnesium is in group 2 and chlorine is a nonmetal. Keep in mind what a cation and anion are. So the name would be magnesium chloride because of the "-ide suffix.
Okay, now let's start with binary 2. So we're going to go over some rules. Binary 2 requires algebra and Roman numerals. It also involves metals, cations that come from groups 3 to 12 in the periodic table, and they have different charges. And they end in the "-ide suffix unless it's a polyatomic. Let's practice now.
Examples, yay! So we have iron and we have oxygen. So the basic equation to keep in mind for binary 2 is the number of cations times the charge on those cations plus the number of anions times the charge of those anions equals 0. So here we have one cation of iron and we don't know its charge. And then we have an anion of oxygen, and the charge, if you refer to the periodic table, is -2. That'll equal 0. 1 times x equals 1x plus 1 times -2, which will be -2, or equal to 0. That turns into 1x equals 2, and then you divide by 1, which gives you x equals 2. Moving on to the naming part of it all. So you're going to keep iron as it is on the periodic table. We add the 2, which is the charge that we figured out algebraically, and oxide with the "-ide suffix. You only don't add "-ide if you're working with a polyatomic. So you always say the metal's name, the charge of the ion in a Roman numeral, and the nonmetal with the suffix "-ide. For more practice, you want to keep the equation in mind. This helps you to solve binary 2 and is completely essential. So we're going to take nickel and chlorine. We have 1 cation of nickel, we don't know the charge, plus 2 anions of chlorine times a charge of -1. This gives you 1x minus 2 equals 0. You add 2 on both sides, that gives you 1x equals 2. Then you divide by 1 on both sides, and then x equals 2. And the way to say this is nickel to chloride because of the "-ide suffix in the end. Alright, cool cats, now let's move on to binary 3.
Let's go over some rules. First rule is that it's a nonmetal plus a nonmetal, so it's going to have to use prefixes. So now let's go over the prefixes. So if we have 1, it's mono, and we don't use it on the left one, we only use it on the right element. 2 is di, 3 is going to be tri, 4 is tetra, 5 is penta, 6 is hex, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Let's go over an example. We have CO2, so that's going to be carbon because there's only 1, dioxide because there's 2 oxygen.
For example number 2, we have 1 carbon, 3 oxygens, so therefore it will be carbon trioxide. And then we have 2 nitrogens and 4 oxygens, so it's going to be dinitrogen tetraoxide. Thanks for watching! Like and subscribe for more videos. See you next time!
Bye!